as we start today's lesson, what I want to do is just get a little bit of a survey from you, okay?
It's a universally accepted fact that girls generally don't do well in physics. But Barry Burndies of Latimer School in Edmonton is convinced that the girls in his class are every bit as good at physics as the boys.
Girls are not bad at physics at all. Girls are equally as good as boys at physics. They just need to realise that.
Whether they achieve their potential or not is down to Barry as a teacher. But he's confident that using the 5 rules of girls in physics, he will engage his audience.
Anybody part of their journey today by bus? I should expect to see a few more hands going up. And finally, at least one other, cars. Oh dear. Now, does that mean that you're lazy, or does that mean mummy and daddy are just very kind to you? I won't ask that question. Okay, we won't ask that question. But today I'm thinking particularly about some ideas of physics that are related to buses and cars.
Observing today's lesson is Martin Hollins of the Institute of Physics. He's keen to see whether Barry's use of these rules is effective.
Well, he started off the lesson in an irresistible way. How did you come here? You know, it's a question that everybody can answer, and nobody feels at a disadvantage. So there's not been a drawing out of anything particularly for the girls, but he knows that the thought of questions he's asking can be answered equally well by all of them.
So, Barry has started strongly. But what are the 5 rules for girls in physics? Number 1. Make it relevant so the pupils see the point of the learning. 2. Be a matchmaker. Group the pupils as you want them. 3. Ideas are king. Welcome ideas from pupils. 4. Know the students. 5. Passion is important. A teacher's passion for the subject will enthuse the pupils. Although these rules are not specifically applicable to girls only, they do help to give the girls a bit more consideration in a subject that has traditionally been male-dominated. Well, those are the rules. But how is Barry going to score? He already has a point for his introduction.
Try and think as wide as possible, as many reasons as you can possibly think of. Be imaginative as well about why somebody might have on the back of their car a sign which says keep your distance. So, Nishalini.
If they have to brake suddenly and there's enough space so the other car don't crash into it.
Great, excellent, thank you. Now, I want you to imagine that you're travelling along on a motorway, somebody in the car in front, their brake lights come on. What I want you to think about is what processes take place, what things are going to happen between those brake lights coming on and you ending up stationary. So, groups of 3, 3 minutes, bullet points, but I want you to all end up with those bullet points in your books.
That's another point for Barry. Using the matchmaker rule, he's already arranged the class into all girl or all boy groups.
Girls get turned off physics because very early on in their science career, they end up being, if you like, almost bullied out of the subject by boys during lessons. Boys get very dominating.
Number 6. 6.
How have you got 6? Why have I only got 5? Well, I've got 5.
You're not enough good, that's why.
We notice that the youngsters are grouped in the room so that the girls sit with each other and the boys sit with each other. Although a group of girls will be opposite a group of boys. But I like the girls to be able to work together so that the boys don't take over. And now I need to select a group to get their ideas. So, Laura, who's your spokesperson? Megan. I'm going to write your ideas on the board and then we will see if we can all feed back some ideas about your ideas, okay? So, brake lights come on.
The person in the car sees the lights.
Person sees lights. Good, got that one.
Your brain sends a message to your foot.
There he goes again. Barry not only knows his students by name, he also knows who will be confident enough to answer questions in front of the class.
One of the things that you have to think about when you're asking youngsters either to answer a question or to be involved in a demonstration is, will they be comfortable doing that?
Then there's friction between the brake pads and the wheels.
His main technique has been to make sure he asks the girls the questions as much as the boys. I mean, you have to attend in this class because the teacher's going to ask you a question sooner or later. You know that.
Anything else there on that we'd like to add in there?
Energy.
Energy, good. The atmosphere in the room is very important, to have everybody engaged and everybody wanting to learn some physics. If I'm spending time battling against youngsters who are completely switched off, that's going to have a negative effect on the whole class. And so to try to get the girls a little bit more involved so that they don't switch off will be a benefit to everybody. So George, we're going to ask George over there, what's happened to that kinetic energy?
Is it converted to heat?
Is it converted to heat? You're asking me a question? Are you going to give me an answer or ask me a question?
It's converted to heat.
It is converted to heat. OK, you're confident about that?
Yeah.
Sabangi, what is it that affects the car to make it stop?
The friction between the brake pads and the wheels.
Excellent, thank you. I wonder how good your reactions are. I'll start this. The car will go along. When the traffic light goes red, I've got to stop it. This car travelled 7.48 metres before it started to stop. Who reckons they can beat 7.48? Fiona, do you reckon you can beat 7.48? Come on, give it a go. Okay, off you go. Ooh, 7.16. Omi, come on, you come out and have a go. Okay, so start. Oh, 5.6.
Once again, Barry's choice of student is based on his knowledge of the class.
Very good lesson, yes. I think if I was teaching it, I'd be really enjoying myself because I think I'm really making a difference to these kids. I'm really getting them to see something that not only is good physics, but will be useful to them.
We're going to focus for the remainder of the lesson on this braking procedure, the braking distance. I want you to think and write down anything, any factor that might affect how far it takes a car to brake. Okay, the actual brake.
Again, Barry is asking the students to contribute their ideas. And by giving them individual whiteboards, he's allowing them all to be involved without having to be the focus of attention.
What we're going to do is you're going to hold your boards up in a moment and I'm going to ask Gudgeon to shout out some of the things that he can see on the boards. OK, off you go.
Speed of car.
OK.
The type of road surface.
Yeah, go on.
The mass of the car.
Mass of car.
Material of the brakes.
Brakes, yeah. Put your boards down and you're going to have to stretch your legs a little bit, you'll be pleased to know, because you've been sat there for a few minutes. What I'd like you to do is come around the middle and you can bring your stools with you, a nice large circle just round here. If I was to say to you, I want you to investigate one of those things on that list, which one of those would you choose to change?
You could change the surface of the road.
Oh, good, I could change the surface of the road. Could I measure the type of surface that I'm using?
No.
Couldn't measure it, so it's a bit more difficult to do, but certainly, and actually practically, we could actually do it, couldn't we? So one of the things in the lab that we could do, change the surface, all right? But is there another one up there that's measurable? A change that's measurable? I'm going to ask Jeremy. Okay, a measurable change.
Speed.
Cool. How would we measure the speed of a car in the lab? Okay, if we wanted to do it, we got weigh, didn't we? We could do that. Electronic balance, pretty easy. Well, what about speed? If I wanted to measure the speed of that car, how would I do it? We're going to ask Chris that one.
You could use a speed gun if you had one, or you could do the thing where you have the light. I can't remember what it's called. Light gate, and then you could measure how long it takes a car to go through certain distances, and then from that you could work out the speed of the car.
So using the light gate?
Yeah.
So if I was to open this drawer up just here and find that in my drawer I've got a car, a stopwatch, a light gate and some wires, would you be impressed?
Yeah.
You would. Okay, with me or with you? With yourself, I thought you might be.
Barry scores again. It was always his intention to measure the speed of the car, but he's allowed the students to arrive at that idea themselves.
We're going to investigate this. I want to know, how does the speed of the car affect the stopping distance? If you're driving along the motorway, you've got to know how far that distance needs to be between you and the car in front so that you can stop safely. I enjoy physics, so I try to put some of that sort of passion, that energy into my teaching. And sometimes the youngsters, they get excited and they get as almost passionate about the subject.
Barry explains how to set up the experiment and then lets the students do it for themselves, in their boy-girl groups, of course. It's not difficult to see the different approaches the groups have. Boys huddle together as a team to get the best results, whilst the girls are less competitive. But the girls noticeably stay on task better than the boys. So, given the differences, can we say which sex is better at physics?
There you go. Yeah. Trying to get my averages.
No, there is that difference, but it's not saying that one has an advantage over the other, that boys are better than girls. It's just how you get on and do it, and the final outcome is that the girls perform actually usually better than the boys. If you look at the performance at the end of a year, girls perform better at science than boys do. How might I look to see what the pattern is? George?
It's like draw a graph.
You could draw a graph, couldn't you? Okay. Hannah, what thing did we control and what thing is going to go on the horizontal axis of our graph?
We controlled the velocity.
Excellent. Yeah, we controlled the velocity, so that's what's going to go on our horizontal axis. Okay, have we got our lines drawn?
Yeah.
Okay, so what have we got here? A straight line or a curve?
It's a curve.
You sure about that?
Yeah.
Why?
Because all my points are around my best fit line curve.
Yeah, but we predicted it's a straight line.
Yeah, well maybe our prediction was a bit wrong.
Or our prediction was wrong, or your group is
a bit dodgy.
A bit dodgy. Okay.
Yeah.
Now, how can we tell whether it's your group that's a bit dodgy or just the prediction that was wrong?
We can look at theirs ones.
Look at their results as well. Okay.
The graph drawn by this group resembles a curve. But do the rest of the class agree?
Okay. And the balance of evidence is that probably it should be a curve. Okay. So we started this by thinking about what speed we were travelling and the distance we were stopping in, because we don't want to drive into the car in front. So we need to have some idea about the speed and distance pattern. So let's just ask a couple of questions to round this up. Arthur, if I double the speed, what happens to the distance?
It squared the distance.
It squared it, so it went up how many times? Doubling it went up?
4 times.
4 times, good, 4 times.
Barry ends the lesson with a quick recap. But how has he performed? He's made the topic very relevant. He obviously knows the students and has grouped them for maximum effect.
He made the link between speed, distance and energy.
Barry's enthusiasm is obvious, and his structuring of the lesson has encouraged the students to contribute their own ideas. So what does Martin think?
The students had to wait quite a long time before they could get up and do something. And I think that's because he had so many things he wanted to be sure about. A, that it was relevant to them. B, that they were drawing on these concepts that he'd had before. He's got the thinking time, which he dealt with quite snappily, actually. And then he wants to get on to the breaking time. So he's got quite a lot of stuff to get through. And it worked. That's all you can say. I think it was an ambitious thing to do, but it worked for this class.
They enjoyed it. I enjoyed it. Yes, I think it was a good lesson, not a perfect lesson. There's nothing that I would have drastically changed in the lesson. Probably they were sat around a bit too long at the beginning, and it would have been nice to have perhaps moved them around the centre a bit earlier, but we can always improve. Everybody can improve, and if we weren't trying to improve, then we're in the wrong job.